Hi Dr. Elaine. I made a simple program. I decided for my numerical calculation, I decided that I'd have a bunch of objects on the screen and calculate the electric fields at different points along the x-axis. The different groups of objects would be, one would be this one. We'll see many dots, balls, and the other would be this one, and the third one this, and there should be another one which I think, over here. Yeah, this would be the other one. And I have all of those initiated over here, and I'm going to use their locations loaded up in these arrays which I've declared over here, and I'm just putting their positions to these different arrays, and I'll have the different locations, the source locations for each source. Then what I've done is run the and I've set up the observation points as along the x-axis, which has been defined over here, and then I've just run this to calculate the electric field by each of those group of objects at the definite separate points, and then have an E total, which would be the sum of the electric fields. And I've stored all the data I have in the in different text files through these and this command. And what I found was, well, I have a bunch of data points, and I compared the different ones. So E1, E2 versus E3 and E4. We see that two of them are pretty close together, except this one, the one with the crosses. The E4 is the one that was really spread out, the red balls, and which is explainable as it's really spread out, so there might be some of the electric fields might be cancelling each other, but and this cross one is what I imagined as all of that charge of the group of objects, because each group has 500 balls. I just imagine it has this ball centered at the origin having 500 times the charge of one ball, and it came out over here, which was pretty strange because thought it'd be closer to this, but at the same time it is explainable, because maybe it's because of this because these are little the magnitude of these don't cancel much, and that's why maybe it's greater. But at the same time, as we go further away, we see that it's really close together. And then I also took out the total of all those four groups of objects and compared it to a charge that's the total of the four groups, which would be 200 objects centered at one point, which is given by the red one. We see that they're pretty close together except at the first point, but this can be explained because the group of objects are spread out, so maybe the group of the objects near the point on near the observation location on the right side would have greater magnitude, and which would explain the higher magnitude of the electric field. But as we go on, we see that they get closer, which is and pretty close together. And yes, this is my numerical calculation. Pretty simple, but simple one, but yes, and that's all. Thank you.